Assalamualaikum and hi, my name is Siti Aisyah Ibrahim. My matric number is 11 DKA 19F1059 and I'm from DKA 4A. Today, I will do a visual lab about water jet force. In hydropower plant, turbines are utilized to generate electricity. This turbine rotates due to reaction force produced when one or more water jets are directed. They generally onto vents or brackets that are fastened to the rim of the turbine disc. The impact of the water on the vent generates a torque on the wheel, causing it to rotate and to generate electricity. The study of the reaction force, which is the application of conservation of momentum principle, is an essential step in the subject of mechanical fluid hydraulic machinery. The objective of this experiment is to investigate the reaction force produced by the change in momentum of a fluid flow as a jet of water swinging at flat plate or curved surfaces and compare the result with the computed momentum flow rate in the jet. The plateau of the study of momentum of fluid flow is the impact of jet apparatus. Water enters the cylinder vertically through a nozzle and then strike a target mounted on the steam. A wet pan mounted on the top of steam allows the force of the water to be counterbalanced by applied masses. Water issued from the nozzle and after drinking the target fire leaf through the outlet hole in the base of the cylinder. The vertical force is measured by adding weight to the wet pan until the mark on the wet pad corresponds with the level gauge. Remove the top plate and transparent cylinder from the equipment and check a record that exits the meter of the nozzle. Screw the 90-degree deflector on the end of shaft. Connect the inlet tube to the bench quick release connector. Repair the top plate of the transparent tank but do not fit the knee nut. Using the spirit level stage on the level the transparent tank by adjusting the fit. Replace the knee nut, then tighten in sequence. Return the top plate level indicated by the spirit level. Do not ever overturn the nut as the will damage the top plate. The nut should only be tightened enough to level the plate. With no weight on the wet pan, adjust the head height of the level gauge in until it. With the datum line on the wet pan, check the position correctly by gently oscillating the pan. Place a mass of about 15 grams on the weight. Open the bench valve to protect the flow. Open the flow slowly and allow it be upon the target until the datum line on the wet pan is level with the gauge and leaf flow constant. Observe the flow behavior during the test. Now measure using the volumetric tank. They achieve by closing the ball valve and measuring the time taken accumulate a non-volume of fluid as then a measure from the side class. Repeat the procedure by adding additional 50 grams each time until a maximum weight of 500 grams is reached. Then repeat the wall test of each of other flow deflectors. The target plate under the knurled screws and remove this from the transparent tank. Take care not overturn the knuckle screw when replacing the top plate as this can damage the plate. When finished taking reading, replace the deflector back to the first one used. Be sure to clean out the station and any water that may have spilled. Following the lab measure, complete the result table and put together your lab report. So this is data for measure values for flat plates. For force, Newton 0.5, average measuring time S is 39.04, flow rate is 1.28 times 10 the power of negative 4. For 1.0, average measuring time is 26.05, flow rate is 1.92 times 10 the power of negative 4. 1.5 is 21.24 with flow rate 2.35 times 10 the power of negative 4. For 2.0, average measuring time is 18.93, flow rate 2.64 times 10 the power of negative 4. And lastly, 2.5, average measuring time is 17.02 and flow rate is 2.94 times 10 the power of 4. So for measure value for hemisphere, 180 degree reflection. For 0.5, average measuring time is 54.82, flow rate is 9.12 times 10 the power of negative 5. 1.0, 36.06 with flow rate 1.39 times 10 the power of negative 4. For 1.5, average measuring time is 27.00, flow rate is 1.85 times 10 the power of negative 4. 2.0 is 27.72 with flow rate 1.80 times 10 the power of negative 4. And lastly, 2.5 with average measuring time is 25.31 and flow rate is 1.98 times 10 the power of negative 4. And lastly, measure value for cone, 135 degree reflection. For 0.5, average measuring time is 82.80, flow rate is 6.04 times 10 the power of negative 5. For 1.0, average measuring time is 41.62, flow rate is 1.20 times 10 the power of negative 4. 1.5, average measuring time is 29.54, the flow rate is 1.69 times 10 the power of negative 4. Then for 2.0, the average measuring time is 24.64, flow rate is 2.03 times 10 the power of negative 4. And lastly, 2.5, the average measuring time is 25.16 with flow rate 1.99 times 10 the power of negative 4. Forget, for all this measured volume is 5 liter. For note, this is the formula for nozzle diameter. We had 8 millimeter and we will change to meter, so we get 0.08 meter cross sectional area of nozzle A, and this is the formula: discharge Q, velocity V, and gravity with 9.81 meter per second. So for the result, flat plate with a flow rate and a velocity for 0.5 is 2.56, for 1.0 is 3.84, for 1.5 is 4.70. Next, 2.0 is 5.28, and lastly 2.5 is 5.88. And calculated force F feet per Newton, the unit is Newton. So first we get 0.66, next 1.47, then 2.21 and 2.79, lastly is 3.46. This is for flat plate. This is hemisphere with 180 degree deflection. For velocity v, the unit is meter per second. One is 1.82, 2 2.78, then 3.70. For 2.0 is 3.60, and 2.5 is 3.96. So for calculated force, the unit is Newton, is 0.33, 0.77, 1.37, 1.30, and lastly is 1.57. And for cone with 135 degree deflection, for velocity v meter per second is 1.21, 2.41, 3.38, 4.06, and 3.98. So calculated force is Newton, 0.15, 0.58, 1.14, 1.65, and lastly is 1.58. Discussion: comparison of the four bodies with completing the table below. So for loading 0.5, calculated force for plate is 0.66, hemisphere is 0.33, and cone is 0.15. For 1.0, plate is 1.47, hemisphere 0.77, and cone with 0.58. Loading Newton for 1.5, calculated force for plate is 2.21, hemisphere 1.37, cone in 1.14. Next, 2.0 with plates 2.79, hemisphere 1.30, cone 1.65. And lastly, 2.5 for plate 3.46, hemisphere 1.57, and cone with 1.58. This is the graph for plate and hemisphere 180 degree deflection. This is for cone with 135 deflection. So this is analysis. Flat plate with 0.5 average measuring times S equal 38.87 plus 39.04 plus 39.20 times divide 3, and the answer is 39.04 second. For flow rate is 0.005 divide 3, 39.04. The answer is 1.28 times 10 to the power of negative 4. For velocity v meter per second, the formula is Q per A. So the A we got is 5.03 times 10 to the power of negative 5, but we changed to negative 4, so we got 0.50 times 10 to the power of negative 4. For velocity v, we use the formula Q per A, so we got 1.28 times 10 to the power of negative 4 divided by 0.50 times 10 negative 4. So the answer is 2.56. So calculated force Fib per Fib and the unit of Newton. The formula is rho times Q times 2 and times V is velocity. So you will get 1000 times 1.28 times 10 the power of negative 4 bracket 2 lastly bracket 2.56 as a velocity. So the answer is 0.66. For hemisphere with 1.0 loading, average measuring time S is 30.21 plus 33.58 plus 44.38 divided by 3. So we get 36.06 per second. So flow rate meter with power of 3 divided per S is 0.005 per 36.06, and we get 1.39 times 10 the power of negative 4. For velocity V, m per s, so equal 1.39 times 10 the power of negative 4 per 0.05 times 10 the power of negative 4. So the answer is 2.78. And lastly, calculate the force Fib, the unit of Newton. We have the formula and equal bracket 1000 bracket 1.39 times 10 the power of 4 bracket 2 and bracket 2.78 as a velocity. So the answer is 0.77. For cone, we get 1.5 for the loading. Average measuring time second 26.89 plus 27.80 times 33.94 per 3. So we got the answer is 29.54 second. Flow rate with 0.005 per 29.454, and the answer is 1.69 times 10 the power of negative 4. Velocity V, we got equal 1.69 times 10 the power of negative 4 per 0.05 times 10 the power of negative 4. So we get the velocity of cone is 3.38. Calculated force Fib, the unit as Newton, equal 1000 times 1.69 times 10 the power of negative 4 times 2 and times 3.38 as velocity. So we get the answer 1.14 for calculated force for cone. For discussion, first, it is clear that the force produced on each of the vent is almost proportional to the rate at which momentum passes in the jet in our experiment. 2. The line should be straight for flat plate and the hemispherical cup, theoretically. 3. For the flat plate, the straight line through the experimental points does not quite pass through the origin of the graph but indicate a small force when the jet is cut off. For this correspond to a small displacement of the jockey weight, and it is possible that the initial balancing of the lever was responsible for this error. Or conclusion, from the experiment we observe that the force on vent is positively linearly related with rate of delivery of momentum. Then our experimental was slightly different from standard theoretical value. We also determine the reaction force on different target and also calculate the rate of the flow through our experiment.